here, and I think you know what the process is like, right? You don't know. You just work there, right? Yeah. Hey guys, I'm the only one between you and the carp that you're eating for lunch, so don't fall asleep on me. First of all, thank you, Kaveh, for having me here. Jalal, Mapar, Department of Homeland Security. I'm from the Science and Technology Directorate. We advertise ourselves as S&T is for DHS is like what DARPA is to DoD, but we're much, much, much smaller. We tend to be a little bit agile in some areas. By way of introduction, I have a portfolio of programs, and they're primarily centered around providing solutions for the emergency management community. As Kaveh mentioned, the title of this workshop is wireless devices, right? We are going beyond RF. In fact, RF is just one component of what we're looking at. But when you look at the entire problem, as Kaveh mentioned, our requirements tend to be pretty ugly. 15, 20-minute mission life. You get a call, you being the emergency response teams. They get a call, they got about 3-4 minutes to get to the site. They have no idea what's there. Could be a house, could be a high-rise. They have no idea if they have maps. They have no idea if the building is instrumented. It's got Wi-Fi, what, this, that, and so on. They have no idea. They're getting into a black box, and they have to go in there, do something, come back out quickly. In the past, they have lost a bunch of firefighters, specifically as part of the emergency response teams. Both directly and indirectly due to not knowing where they're located. So when you look at some of these reports that come out, when you look at some of the casualty reports, so-and-so's firefighter died because ran out of air, inhaled smoke, and so on. Problem is the IC, the incident commander who's outside, talks to them on the radio. There is no situational awareness for that guy. Has no idea where they are. So for us, number one problem statement is we want to save lives. And I say that as a matter of providing a contrast between what has been talked about so far, because from the commercial point of view, you're looking at millions, if not billions, of general population and trying to give them LBS for a service to help them with social networking, finding friends, going to the hardware store, aisles, products, and so on. For us, it's just lives. But in the same light, the infrastructure that we go after looks the same. You see this building? What do you think that is? It's just an office building, right? Happens to be in Asheville, North Carolina. How many stories do you see in there? 7, 8 maybe? This is July 2011, last year. There was a fire. Just pay attention to this very short clip. This is the real communication between the incident commander and the guys inside. This was about a minute and a half, maybe about 2 minutes, of about a 55-minute conversation. The outcome of this was that a firefighter died in that fire, ran out of air. And this was big last year in Asheville. That's just one. And I have to tell you, U.S. Fire Administration does a lot of studies in terms of looking at the consequence and the impact, the economic impact of losing firefighters and emergency responders, and translates that into dollars. There are reports out there, and based on the numbers, which range anywhere from about 50 to about 70 per year, the cost in terms of training, loss of life, family, lawsuits, medical, training, education, all those activities adds up to about $3 to $7 billion a year. Just remember that number. So that's the problem we're going after. So what is public safety for us? Public safety for us is the entire emergency management community that includes firefighters, EMTs, hazmat, bomb squad, and then crossing over into law enforcement that includes cops, police, et cetera, et cetera. Here's a variation of the numbers that you see in there. If you do the right permutation on these numbers, depending on what you're looking at and how you add them up, the user community for us that we're trying to serve is about 2 million people, 2 million users. That's a combination of firefighters, law enforcement, hazmat, all of those guys together. So in comparison with the numbers that you guys are looking at from a commercial sense, that's nothing, right? 2 million in terms of billions, we're talking about getting to about billion and so on. That's nothing. But the value for us is saving lives. And that's important because of the exposure that we get out of that and also the missions that these guys have to go into. So what's the need? Necessity is the mother of all inventions, right? Here's what we're looking at. Geolocation, tracking capability has been identified by this community as their highest priority. So 11 years after 9/11 and the Worcester fire that people constantly refer to, the fire that I showed you, just one example. There are many, many more of that. The Charleston fire, non-firefighters died in that warehouse that you see on the right-hand side. After 11 years of 9/11, we lost about 343 people there, not necessarily because they didn't know where the location was, but it's just a combination of all those things, including not knowing where their location was. We still don't have an accountability system that can monitor, track, and find the location of these guys as they go into buildings so that the incident commander can see that track on a computer. So the need for geolocation for public safety from a DHS perspective is very simply 3D. Not so much 1% of distance traveled has to be less than 5 meters. We want X, Y, and Z. And typically, just by citing some numbers for you, 80% of these fires happen to be at residential places. And the typical floor height for each floor is about 10 feet. So we settled on an accuracy of 3 meters in X, Y, and Z, because the users tell us that they want to know which floor they're on, and from an XY perspective, which area, which office, which door. We put these requirements together. We also have some other requirements. Earlier this morning, there was talk about should the government get involved and see if they can do something with the standardization, et cetera, et cetera. Well, when you look at the fire community, there's something called NFPA, National Fire Protection. There's a bunch of standards that we have to follow. So talk about our requirement from an accuracy point of view being really stringent. We also have to abide by those requirements. I think one of the most significant ones is the system, the technology, the solution that we develop has to be intrinsically safe. Does anybody know what that means? What that means is that just imagine that you've got a device on you and you have no idea what situation you're getting into. It could be a bad case, right? It could be a bad day. You don't want to carry an RF device with you, go into a building and trigger maybe a package or something that gives you a secondary explosion. So that means that it has to be intrinsically safe, that it's not propagating, sending anything that might trigger some other things. So the key requirements for this community is that they want situational awareness. And, oh, by the way, this community is not as rich as some of the other communities. For example, the DOD, the warfighter community, they don't have money. So the key point that we constantly joke about is that this community wants a device that weighs nothing, costs nothing, and generates power for them as well. Here are some of the requirements. I think these have been there for the past 5 years. They haven't changed. If anything, the accuracy requirements have got really bad. We started with 3 to 5 meters. They told us they want us to go down to 1 meter. And typical of everything else, listen, it's a trade-off between cost of the components that you put in that cell phone and the accuracy that you're going after, right? What's more, they don't want any infrastructure. Look, these guys, when they get in there, they've got about 3-4 minutes to get into the building and come out. There's no time to set up a tripod, antennas, tags, Wi-Fi, APs, et cetera, et cetera. They just want to go in there. You turn it on, go in there, and they want to be tracked. No breadcrumbs. That was number one from day one. Although I have to tell you, after looking at this for the past 5 years and kind of looking at these programs, they are agreeable to maybe having a little bit of a breadcrumb. Not bread loaves, because if you look out there, there are bread loaves that look like really huge. What does the concept of operation look like for us? So these firefighters in the fire department, right? They get to the building, boom, teams go inside. And the idea is that they want to have a device that could be integrated with SCBA, the tank that they carry with them, the air tank, or it could be integrated within the so-called PPE, that's the suit that they wear, the personal protection equipment referred to. So it could be embedded within that. So they go inside and they go in one, maybe typically 2 or 3 guys go together, and the incident commander who's outside wants to have the situational awareness in terms of what you see here in the lower left-hand side by way of looking at the floors. This is indoor. Now remember, we don't have any maps. If we have maps, even better. So that's what they wanted. They get in there, go inside, turn the unit on, and it has to work and send the tracks outside. I was going to give you an idea of what's out there, but I'm going to skip that because I think all of you know what is out there. I think everybody understands and appreciates that this is a major challenge, and there aren't really any products that are shrink-wrapped, if you will, that you can go and buy and then use. There are variations of solutions. Each one has a capability. So I'm going to skip this one and for the sake of saving some time here. But as you know, there are a large number of companies out there that are looking at geolocation, whether it's RF-based or what I will talk about in just a second, the cocktail solution that includes other components. And everybody has a solution. One of the main issues, as I said before, for the community that we're serving, cost is an issue. So some of these solutions tend to be very expensive. And there lies this challenge that I think applies to both the RF-based systems, the commercial community, as well as what we're trying to do for the DHS community of users. So from DHS, I've got a program called Glancer. It's a mouthful, but it really tries to capture the essence of this program, which is navigation, accountability, tracking for the emergency responders, 3-dimensional. So what we've done is, as Kaveh and many of these you speakers in the morning talked about, you know, RF is not enough for us, unfortunately. That is to say, time of flight is not enough, especially with the problems that we run into. Multipath is the biggest one. You cannot rely on that because, you know, you do peer-to-peer ranging and you go around, especially in a building that has got concrete, metal, steel. All of a sudden, boom, boom, the signal is all over the place. You do time of flight and it says, you know what, you're in Baton Rouge. It's just too bad. So what is the Glancer system? Our system, the generic version of this is the unit that you see in the middle that looks like a box. That's the locator unit, and I'll tell you what's inside there in just a second. The emergency responders get to the site, they grab one of these, plug it in, it's a clamp, and turn it on, and that's all they have to do. The unit has already been initialized. As far as the system overview, I showed you the generic version of that in a previous slide. This is what we've got now. So you look at some of these acronyms, and because we are part of the federal government, we want to invent our own acronyms, of course. So we've got a geospatial locator unit. It's called GLU, GLU. That's the unit, that's the locator unit. Then on the commander side, he's got a base station, and on there, he's got a laptop where he's got the visualization software. Now, remember I said we don't have maps? We've got some technology behind this that allows us to start with the outside of the building using the Google maps that we have, pretty much doing a perimeter draw it, and then depending on what the IC sees and kind of says, well, it's probably about 20 floors, boom, 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 20 floors. And as they go inside, the tracks will show on this. Now, during transit, if we have access to the maps, and again, talk about standards, we can ingest anything from PDF maps to CAD models and so on. We can just keep that in there, boom, use it very quickly, if they know where they're going. And cross your fingers that the new owners of the building did not remodel the house and change rooms or cubicles and office space and so on. So this is the GLU. This is the locator unit. And it's got a bunch of components within it. It's worn by the responder. And right now, those are the components that are in there. So in addition to RF, we rely on an IMU. And I have to say that the way we went about this is we completed the development of the system, and after about several iterations and spirals, Honeywell is the prime contractor for us, and we've got Amit Kulkarni from Honeywell who's sitting there spying on me to make sure that I get the right story, correct? That's the unit that they're developing. That's a mock-up of what you see inside. So the combination that we've got is, of course, GPS. There was a mention of seamless transition from outdoor to indoor. That's exactly what we do here. When you're outside, while in transit, you turn the unit on. It's on the panel on the fire truck. It requires GPS, initializes. By the time you get to the site, everything is initialized, ready to go. You pick it up and go into the building. GPS dies, and you rely on the IMU, on the Doppler velocimeter, the radio ranging that we have in there, and a couple other components, the altimeter, the barometer for altitude determination, and so on. We've already talked about this, and a little bit of that, so that if you're a cop sitting in the car, you still have access to the visualization on the laptop that they usually have there. By the way, for the technical guys, in case you're wondering what the architecture looks like software-wise, you can probably guess what this is. You get all the sensors on the left-hand side, and of course you got the Kalman filter that filters everything for you, gives you the navigation solution. Now, one difference is that with the system that we have, the user, the first responder, does not have a view of looking at the track on his own. So the device computes the navigation solution on the spot real time, and then that navigation solution is transmitted back to the base station to the incident commander. Like I said, we've been working at this for about 5 years in different forms, from concept evaluation all the way down to this cycle that is taking the results of R&D that was done, is being done, and transitioning it into a viable product for the first responder community. So please keep that distinction. We are not trying to compete with what you're doing as far as geolocation for the mass population or warehouses and other places where you have to rely on the databases, the APs, and knowing those in advance so that you can do triangulation, whatever you want to do. This is precisely intended for the first responders. It's a very specific case. But I contend that if we solve this challenging problem, there are bits and pieces that can be transitioned, leveraged, used for the solution that you're going after. Here are some of the activities that we've done. The most recent one was at the fire department instructors conference in Indianapolis about 2 weeks ago, I believe. We had the units there, and Honeywell had a big booth, and they kind of did a few demos of the system there. What's coming down the pike for us this year, this is a critical year. As I'm sure you know, the budget times are pretty tough, and we were not immune. We took a big hit at DHS S&T But this program was given a go-ahead to keep going because the user community is asking for it. But here are some of the activities that we're doing. So the most important upcoming event is in the summer timeframe. We're going to the DC metro area with the units, and I'll show you what they look like in a second, to do some testing with actual firefighters in a simulated environment, not running a fire or anything like that. So cost is important for us. So transitioning this technology from R&D to a product is also important. The other important piece is, of course, swap. And I have taken the liberty of taking size, weight, and power, turn the and into automation, because automation is important. So swap for us means size, weight, automation, and power. Some of the considerations: price strategy. Our user community is not that rich. They can't afford thousands of dollars. So what we are proposing, pushing for, is some sort of a business model that mimics what the cell phone industry has done. Maybe give them the hardware at a reduced rate, give them to sign up for a 2-year, 3-year, 5-year contract per user base, and so on. You can amortize that. There are games to be played in that regard. If you look at the unit that we have, the locator unit, the bill of materials right now is about $3,000. There is no way that our first responder community can afford that, let alone the general population. So you see what I mean by trying to be clever and creative about the business model so that you can spread the cost over a number of years so that maybe it translates into maybe one of these LBS revenue generation schemes, right? You want 10-meter accuracy, it's $5 a month. You want 5 meters, it's $20. Maybe, I don't know, get down to 1 meter if you can get to it. It's 25, 30, whatever that is. So there's a combination to be paid. The other thing that we're looking at, again, specific to DHS user community, there are huge fire departments like New York, 25,000, 30,000 firefighters. And then you've got smaller communities, 5, 10, 15. And by the way, did you know that out of the 2 million users that I mentioned to you, the firefighters, about 75 to 80% of them are volunteer firefighters, and the rest are professional ones, full-time. But we don't distinguish them. We see them as all users. So where are we today? In 2010, when we put all of our units, components, and things, we called that a shoebox. It was about this yay, and about this thick. The prototype units in 2011 are beginning to look like the green box. And then we went away from that, and now the test units that we're using this year are the black box that you see there, or the black brick. In late 2012, by the way, those are the sizes in inches. And if you remember from our requirements, we want this to be less than a pound. Way less than a pound. So in 2012, those units, we're hoping to get them down to about 3 by 4 by 7 inches. In comparison with an iPhone, those are the measurements that you're looking at. Now, why is the box so big? Well, a lot of that real estate is taken by the battery, right? The other part of it is the IMU that we use right now is pretty big, hefty, but it gives us darn good performance. So we're trying to move away from those bulky pieces and taking the battery out. And oh, by the way, I've got a couple other programs looking at next generation batteries and generating power out of temperature differentials and so on. If we can take those out, we can shrink that box even more. So miniaturization is also a big requirement for us. You see some of the requirements there. Our eventual, in the BAA that we put out, we asked for 2 by 4 by 6, but I think we can get it down to smaller than that. What does it look like? How will it be used? Right now, one of the options that we're looking at is that it will sit right next to the SCBA tank. And it will be tied, integrated with the valve so that when they turn the valve on, the unit is already on and it communicates and starts sending messages back and forth and navigation solution and all of that. That's one possibility, one option that we've actually tested. In February, we did some testing with Plymouth Fire Department at Honeywell's location. And The users during that test were pretty happy with the location of that unit. What kind of accuracies are we getting? I'm going to kind of steal the thunder from you. We are, generally speaking, on the average, we're getting better than 3 meters in X, Y, and Z. And the numbers that we get for altitude are much better, actually. They're in the order of about 1.5 meters. Now, the big challenge for us is to get it into an actual scenario where there's fire, there's temperature differential, positive pressure, negative pressure, all the stuff that's happening in the building to see what that looks like. As far as the user interface, this was developed with a lot of input from the user community. Now, here's another key challenge that we face. If we talk to 10 different fire departments, we get 10 different answers. So some like just the 2D wire diagrams. You can see the lines. Others like to see the three-dimensional view with color coding and everything else. And oh, by the way, this system is going to be tightly integrated with a personal alert safety system, the so-called PASS device, so that if a responder is not moving for about 90 seconds, it issues an alarm so that the incident commander can see that something bad has happened and they know exactly where to go and save the guy. We did some testing. Come on. Just to give you a heads up as far as what you're saying, this is our building, the DHS Science and Technology Directorate in DC. It's on Vermont Avenue. It's about 12 floors. And we had the team over there to set up their base station on the 6th floor in a conference room. And we had 2 guys with the units on them, asked them to go around and go up to the elevator to the 6th floor, to the 8th floor, and come back and so on. We talked to our building facilities, and to get the maps, they had the PDF versions of the floor maps. So within 2 minutes, we just kind of put them in there. And let's see what that looks like. This is running faster than real time, of course. But those are the type of tracks that we get. And then on the right-hand side, you see it there on the 6th floor, 2 dots, and they're going to go up. So there's one. If you notice, the circles went from green to yellow. That's because our building is pretty tough. There's a lot of concrete glass, and in some areas, there's a building behind our building. So the signal just went away. But the moment they moved away from that corner, they picked up again, and they were able to track. This is another one. We started from the ground floor. 2 guys didn't have the maps for the ground floor, so all you see is just the tracks. And then they go up to the 3rd floor, and they come back. So the accuracies that we were getting out of those, including while the time they were in the elevator, going up the elevator shaft, was actually better than 3 meters. The yellow circles that you saw, when we looked at the results, there were areas, like I said, we just didn't have the data, but we have a card within the device, so it captures that information and it sends it out. So the information was there, and we were able to do some analysis on the accuracies as well. We support the WPI workshop, which is another one at WPI, by one of Kave's colleagues, Jim Duckworth. And that's where the focus for that workshop is entirely precision indoor location with applications for Homeland Security kind of users. And we're going to do that again this year. and we are going to demonstrate the Glancer system for the first time with Worcester Fire Department there in one of the buildings. Last year, we had about 140 people, 45 attendees. And if you're interested, let me know, let Kaveh know, and we'll make sure that you're there. As far as what's coming, like I said, this year we're planning to do some testing in the DC metro area in Maryland, the Maryland Fire Research Institute. And then in Prince William County, Fairfax County, if you're familiar with that area, there are a couple of big fire departments there. Put Phoenix and Las Vegas in there in gray because depending on how much money we have, we'll probably do those as well. So, Kaveh kind of stole the thunder from me with multipath. Hey, it's the biggest problem right now, okay? If you guys can help with that, sign me up. And if I solve it, hey, you can have it too. It's government funded, right? Taxpayer dollars and so on. You can leverage that and use it in any way you want to. Ranging, signal penetration, still a big issue. I think somebody else, I'm not telling you something you don't know. I saw the presentations this morning. Everybody wants something that's robust, maintainable, predictable, repeatable, right? It's the same set of things, but applied to a different set of customers. Because even if in the commercial market, if you're providing a solution, look, your average population doesn't care, doesn't want to know what multipath is. They just want to know where they are. If you're not solving it for them, if you're not giving them the solution, they're going to call back and say, give me a credit on my thing, right? So that's where the robustness comes from. Must be easy to use, cost reduction, cost. That's a big problem for us. And here are some of the gadgets that they carry with them. So weight is also important. They want this unit to be pretty light. So in conclusion, we started with this problem statement that said the incident commander wants to know where his forces are at any time in real time. Up until 5 years ago, there was nothing. There were bits and pieces. But I believe today, this year, not just what we're doing with Glancer, I think with everybody kind of looking at this problem, Skyhook, Qualcomm, Broadcom, all these other companies out there, Verizon, from everything from the network side of it to the sensor side of it to the integration to providing a solution that works, I think all of those pieces are converging. So I think I'm pretty confident in saying that now we can tell where you are with some degree of accuracy and confidence level. Now, let me also finish with just one thought for you. Kaveh and I were talking about the role of government and what we're doing with regards to specifically this program. If you think about the Apollo program, do you have an idea how much the government put into the Apollo program? And JFK said, let's go to the moon in 10 years or less and so on because it was important. Can you venture a guess? Anybody know? I think the numbers that I recall are in the order of maybe $12 to $14 billion, right? So we put a man on the moon. Now, government spent that much money on that. Do you guys have your own rocket? I sure don't. So the role of government is not to develop something and mass produce it and give every individual a Saturn rocket so that you can go to the moon and back. But you know what? Think about it. All those things that came out of that program. And if you talk to anybody, you guys should know this. The entire PC computer industry, all kinds of sensors, avionics, IMUs, everything that you can imagine. Navigation going back to the days of using star trackers for planetary missions and so on. And then somebody saying, what if I could use this here? What if I put some GPS satellites up there? All of those things really excited people in terms of thinking out loud. There was R&D involved, but really didn't know what we were getting into. And all of a sudden, you ended up with the computers. Going back to the 4K RAM, going to the shuttle program with the original computers, the GPCs, general purpose computers with 16K of RAM. 16K! And then Bill Gates comes in and says, 640K of RAM memory should be enough for anybody. Listen, this gadget here, I got a card that's got 4 gigabytes on it, and it's still not enough, and it's cheap. So the role of government, what is the role of government? What we're doing is we're trying to incite, excite, push, prod, by way of looking at a specific problem for which we need a solution to serve 2 million people. We are trying to excite you guys to think beyond the sandbox of just solving this problem, see what's available. Because I think by way of doing that, you're looking at billions. So everything we're developing here, the GLU that I showed you, it's huge. It's not going to fit in a cell phone right now. That's not what you need. But you know what? Some of the research that we're doing in terms of solving some of these algorithms, maybe some of the components going to the MEMS IMUs, smaller, 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 hopefully that will be of use to you at some point. And that's what I see the role of government, really. I mean, it's a combination of being a VCC, hedging your bets, taking risks, getting people excited about solving something. I love the laws of unintended consequences, because you never know what you're going to get. And that's not quoting Forrest Gump. Thank you very much.
You talked about the cell phone operator model as a possible model. So who would be a potential operator in that case? Not an operator, but the entity which would look like an operator.
Right. Specifically with the program that I just talked about, you will have manufacturers who will produce the system. I would say starting with Honeywell. So that's going to be a self-contained system. So the whole idea is that maybe a company like Honeywell or others who will produce their own separate systems could look at the cell phone model as a way of mimicking that. So it could be tied to maybe collaboration with the network providers, or it could be by itself as they develop the product into a viable service line, if you will. Yes?
Just a clarification. The 3 meters accuracy is 50 percentile error?
It's what?
Is it a 50 percentile error, 3 meters accuracy?
50% what?
50 percentile error? Is it a median
What's
error?
the percentage? 50%?
No, more than that.
So
The so-called CEP, circular error probable, it's about 95%.
95%
Yes.
below 3 meters.
That's why we call it precision. It's important. Yes?
Typically, for inertial systems, the accuracy is also a function of time. So the 3 meter you're requesting is over what, 1 hour, 10 minutes, 55 minutes?
The requirement that we have for the system is that it has to operate for 4 hours. And it comes back from a couple of things. The life of the battery and a couple other things. But for each sortie, which is about 15 to 20 minutes, if we can get the 3 meters of accuracy with a CEP of 95% for about 15, 20 minutes, we're golden. Because the moment they come back, they can recalibrate or put the unit down, get another one, and go inside again. Because as you know, the biggest problem with the, I'm sure you guys know, of course you know this, the biggest problem with the IMUs is the drift.
Do the firefighters also have the display where they are inside the building?
Yeah, typically what happens is, if, for example, think of this building. If they come here, they usually, the trucks are outside, and if they can, they usually set up their base station inside the lobby, or the command post inside the lobby. If not, they're outside. So one of the requirements that we have is that the units have to be able to communicate with the base station a minimum of 100 meters and higher. So that gives us enough distance to set up the base station outside. Yes?
I may miss this, but is the positioning based entirely on the IMU?
No. It's a combination of the IMU, altimeter for altitude, RF ranging, peer-to-peer ranging. There's a Doppler velocimeter in there. Was there a pointer here? You see the unit that says test unit 2012, 3 by 5 by 10? You see the two faces? Those are the Doppler velocimeters. So it's a combination of these sensors that we've put in there. Again, on the architecture side of things, there's an IMU, magnetic sensors, altimeter, GPS scores, Doppler, radio ranging, and we also allow for map correction in case we have the maps. So all of those things are in there. And that's what I've been referring to as the so-called cocktail solution, because it's a hybrid solution.
So where does the cleverness lie? Is the cleverness in combining these?
Yes, yes. And also the mitigation, you can think of it as the mitigating algorithms in there, accounting for corrections to, multipath, although it's not 100% there yet. Yeah, it sounds kind of routine, doesn't it? Right, just put these things together and send them through a common filter, done. Not that easy. Great. Yes?
There are a lot of these sensors, like IMU devices inside like iPhone.
Uh-huh.
Did you have anybody to look to
Yes.
see the capabilities
Yes.
of those and compare it
Right.
with the capabilities of your devices?
Right. So, good question. Your iPhone has got your iPad. You turn it, that's got the gyros in there, right? But they're cheap devices because they're for mass population. So they're also automotive IMUs, $5, $10. But like I said, the drift will kill you within 5-10 seconds. So you can do one of the other things. We talk about combination of things. The zero update, dead reckoning, update velocity. I mean, it's all included in here, plus many other things. But the performance that we get out of the cheaper components kills you.
But have there been any quantitative study? Because one thing that is important for the commercial,
Yeah.
like anybody, like a Skype, etc., is that can they improve their localization with the other sensors inside like iPhone, let's say. So if my question is that have anybody has done a quantitative study? Just look at this thing and say that, listen, if you use the sensors inside the iPhone, your accuracy, which is 15 meters, goes to like 9 meters, for example. Something like that I think is valuable for commercial and is valuable for you guys because the future, these devices are getting better and more less expensive.
Right.
It's a sort of like merger of the two.
We have not done a study the way you describe it, although during the selection of the sensor components, we, in the past 5 years up until now, we've done studies looking at the type of sensors out there that are now being used for mass population. In fact, the gaming, like the Wii or some of the other devices, just by way of comparing performance. We haven't done, if you will, the second order analysis that says, okay, so if I use this one, how does it improve my accuracy? And, the ripple effect in this, we haven't done that.
I think that my personal belief is that something like that is very helpful
Yes.
for commercial and also for military to address that question of cost.
Definitely. And in fact, since he was out of the room, I can blame Nader for this because he's from NIST, and the idea, he keeps pushing for doing a study like that to understand the impact of sensors, 3-4 dimensional, right? How many sensors, what performance, and what's the ripple effect into a system of sensors? So where's the, do you have the report yet?
Which report?
See, that's exactly what I mean. We can't rely on these guys to do the work for us.
That's very fascinating.
Yeah.
Because, as you said, the thing is like a cocktail.
Yeah.
I mean, indoor geolocation, if you want precise indoor geolocation, you must go to the cocktail solution. And in the cocktail, it depends. I mean, if you have triple sec there, you put it. If you don't, you put lime. You know what I mean? So
Well, Kaveh, in fact, that's a very good comparison. And I would say if you want a margarita, you can have 1800 in there, tastes really good. Or you can have some cheap tequila with a headache in the morning. So,
a study of
yeah.
that, I think, is good for the bartender.
Definitely, definitely. So it's $2 chuck versus some $50 bottle of wine. It tastes good, right? No headaches in the morning. Anyway, I hope you enjoyed it, and thank you for staying awake. Thank you.